afternoon, my dear students. Let me welcome you to my next video lesson on indices, and it's going to be a bit more kind of variations when it comes to indices. Indices, to begin with, it could be the simple as it is. At the same time, even it could be with much more variations and complexities involved. It all depends on the structure of the problem. It all depends on the variations that we are going to address. Anyway, this is here the regular equations, the regular laws of indices, and you need to have one more law to this, as it is said in my previous video. 7 plus ab to the power of m is equal to a to the power of m into b to the power of m. Now, and if you say that these things are already discussed, and I'm going to have uh, more of such examples, like so this is already discussed, and even okay, this prove that is discussed already. Now this is one more problem. In the earlier case, it was all numbers, and nth root of a is discussed, but here in this case it's about all algebraic expressions. This is what I said, variations when it comes to indices and its applications. Now we say that fifth root of x to the power of n into x to the power of m by p into qth root of x to the power of n divided by qth root of x to the power of minus m into x to the power of n minus 1 into x to the power of m plus 1. If you have understood my previous problem with respect to the roots and applying the law of nth root of a, similarly you can solve this problem too. But here it is all about algebraic expressions. Okay, you can have any numbers for x, p, m, and q, but here in general, okay, we have one problem here. Now, if we say that this is fifth root of x to the power of n, directly can be written as x to the power of n into 1 by p, or it is n by p. Now this is x to the power of m by p. This is x to the power of n by p, and this is x to the power of m by p. And next this is going to be x to the power of n by q. Qth root of x to the power of n. Okay, it is 1 by q here. I am just replacing the square root. I'm just applying the laws of indices appropriately wherever it is required. I'm selecting that particular relevant law and applying it. I'm not doing any miracle. I'm not doing anything great or special. Okay, it is all about application of different laws at the respective or appropriate times required. Now this is x to the power of minus m divided by q. Qth root x to the power of minus m into 1 by q, and this is x to the power of n minus 1. I am writing it as it is. Now this is going to be x to the power of n plus 1. Now see, numerator, the base is same, x, x, and x. Now this is going to be x to the power of, this is n by p plus m by p plus q. uh, this is n by q. This is x to the power of n by p, x to the power of m by p plus x to the power of q by sorry, n by q. Now if you say p, p, and q, and the LCM to be taken. Now here the LCM is pq. That's it. Now if you say this, the second one, the denominator side, this is going to be x to the power of minus m by q plus n minus 1 plus m plus 1. I am applying the law. One is with respect to your the root conversion. This is nth root of a. Next, I am applying a to the power of m into a to the power of n is equal to a to the power of m plus n. I'm applying the second and the sixth law, one after the other as it is required. Next, if you go for this equation here, simplification part, the simplification part is further continued, saying that this is, as I said, x to the power of n by p plus m by p plus n by q. Here, denominators are p, p, and q. The LCM is pq. Okay, this we need to have a bit of mathematics and basics of algebra. Okay, to say how P, P, and Q will be having LCM as PQ. Okay, next, this is x to the power of m by q plus n minus 1 plus m plus 1. If you say that plus 1 and minus 1 is cancelled, now this is m plus 1 minus m by q. Now q is LCM. Now if you say this q is LCM, okay, now this is x to the power of PQ. If you say LCM, this is I can simplify this p and p. You can denominators are same, just add m and n. When denominators are same, you can directly add the numerators. All the basics of your fractions. Okay, now this is p and pu, and pq is LCM. Here is pq, and the denominator missing variable is q. Q into n plus m. Plus here q is there, that is LCM is PQ. We say that, okay, you can multiply this by P on both numerator and denominator side, and this is going to be NP. This is x to the power of Q into n plus m plus NP divided by PQ. I explain it again. Okay, here the LCM is PQ. Now this is PQ. If you say LCM, the first two parts n by p and m by p, denominator is same, therefore you can directly add the numerator m plus n, and pq is LCM. If you say p and p, q is missing, okay, are multiplying both numerator and denominator by q if you say, and this is going to be n plus m into q. Now np, if you say that, denominator q is there, and the same LCM is applied here, and this is here we're going to apply p and p, both numerators and denominators. That's what the basics all about. Probably we are all knowing about this LCM, how these conversions are made. Now this is x to the power of q into n plus m plus np divided by pq, and the denominator side goes to the numerator, and that changes the sign. They're saying that a to the power of plus m is equal to 1 by a to the power of minus m, or a to the power of minus m is equal to 1 divided by plus m. Look at this law. This is, you can use it in the reciprocal sense too. Here if it is plus and here it is minus, if it is minus and here it is plus. This is the law of reciprocal kind of thing, and it explains the principle of reciprocity of your indices. Now this is the simplification here, x to the power of q into n plus m plus np divided by pq minus m plus n minus m by q, and here, okay, you can take pq and q as LCM, and the same thing here, you can take pq as LCM, and you can simplify it further. There it could be one more step further. I'm just leaving it to you for the next step of simplification. If you have any specific queries, okay, you can write to me or you can call me, okay, for the next step of its simplification. Okay, it could be further simplified, but okay, for the time being, I'm just stopping it. I'm just giving it to you, kind of homework like kind of thing. You can practice it. You can do it on your own. And the thing is that you can combine these two powers, and you can simplify it further. Okay, thank you. If you have any particular queries, you can call me or you can text me. You can contact me, no problem. Now this is the second one of this session is 5 into 2 to the power of x plus 3 minus 7 into 2 to the power of x plus 3 divided by 2 to the power of x plus 1 plus 6 into 2 to the power of x. This the whole problem is a bit unstructured. Nothing of that kind of no symmetry that you can be looked here. Okay, there are x plus 3, x plus 3, and it is x and is plus 1, and minus, and this is plus, and there is multiplication again here, like that. Anyway, I'll just continue here. This is 5 into 2 to the power of x into 2 to the power of 3 minus 7 into 2 to the power of x into 2 to the power of 3. Okay, to remind you, here I'm applying the law. Okay, this is a to the power of m plus n. If you say a to the power of m plus n, okay, you can write it as a to the power of m into a to the power of n. See, this law you can use. Okay, either you can read it as a to the power of m plus n is equal to a to the power of m into a to the power of n, or otherwise also it is a to the power of m into a to the power of n is equal to a to the power of m plus n. You can use it in either way, whichever that is applicable, okay, in the given situation, that can be uh, applied, or that you can think of using it in a right sense. That's it. Okay, now this is going to be 2 to the power of x and 2 to the power of 3. I'm just splitting this plus and making it as 2 power x and 2 power 3 minus 7 into 2 power x into 2 power 3 divided by 2 power x into 2 power 1. The same thing, a to the power of m plus 1. Here m plus 1 is x plus 1. 2 power x into 2 power 1 plus 6 into 2 power x. Now look at this. Here 2 power x is common throughout. 2 power x and 2 power 3 both are common. Okay, here in the beginning we have taken 2 power x as common. Now this is, if you say 2 power x is common, 5 into 2 power 3 minus 7 into 2 power 3. This is 8 5 minus 7 8 you can take. 40 minus 56 you can take. 2 power, uh, this is 2 power x and 2 power x. This is some no, yeah, okay, fine. Again, we have 2 power x in the denominator, 2 power x and 2 power x, and 2 power x. If you say 2 power x divided by 2 power x, you can directly cancel this, or you can say 2 power x minus x. This 2 power x is going upper side, and this is going to be 2 power x minus x. Now this is going to power 0. This is 40. 8 5s are 40 minus 7 8s are 56, and divided by, again, if you say this 8 is because of this. Okay, I've taken 2 power x common here, and 2 power 1 and plus 6. This is going to be, just 2 plus 6 is 8. 2 power 0 is 1. 40 minus 56 is minus 16 divided by 8, that is equal to minus 2. This is what exactly the simplified form of 5 into 2 power x plus 3 minus 2 into x plus 3 divided by 2 power x plus 1 plus 6 into 2 power x. This is a simplified form. I explain it again, okay, for your convenience sake, okay, so that you can understand it better. This is a simple case where you can understand all the laws, okay, with ease, with very, no, in the simple sense you can understand this. We say 2 to the power of x plus 3, that is 2 power x into power 3. This is 2 power x into 2 power 3. What I am to say that in the numerator and denominator both, take 2 power x and 2 power x common. If we take 2 power x is common here, this is going to be all numbers, no variables. Okay, 5 into all constants, I mean to say that 5 into 2 power 3 is 8, 7 into 2 power 3 is okay, that is 56, and this is 40. Now in the denominator, if you take 2 power x common, here 2 and here 6, this is going to be 8. Now this 2 power 6 and 2 power x, either you can directly cancel it, or you can apply the law a to the power of m divided by a to the power of n. Okay, we say a to the power of m divided by a to the power of m. If you say that case, a to the power of m minus m, that is a to the power of 0, that is equal to 1. Here a is 2, m is x. That's what the law is. Algebra is very easy, very simple. Okay, only thing is you need to know how to relate it, how to understand or how to relate it. Algebra is very simple. Okay, it all depends on your application part. Now 40 minus 56 is minus 16 divided by 8, that is minus 2. This is what exactly the simplified form of this. Next, I'll go for fourth root of a to the power of 3 and the square root of a. Let's look at this. This is what I mean to say, that the different variations. It could be even the earlier one, it could be for 5 marks. Even this one, it could be for 5 marks. Now the this problem, this prove that case. This prove that case, it could be for 10 marks. Now again, the first one, okay, this could be okay for your 10 marks. Okay, either it could be for 10 marks or maybe it is for 5 marks. Now even this maybe for 5 marks too. Simple case. Now this is for 5 marks. You can expect it for 5 marks. Now this is fourth root of a cube square root a. And if you say that, and this 4 is applied for both of this, a power 3 and square root of a. Now a power 3 cube root of a whole to the power of 1 by 4, applying the equation nth root of a. And if you say a to the power of 3 square root of a to the power of 1 by 4, now I can simplify this as a to the power of 3 by 4 into a to the power of 1 by 2 into 1 by 4. Okay, apply the relation nth root of a. Okay, remember this again and again. I am taking you through the learning of the laws of indices. This is very much essential. You should go through the learning of nth root of a and this a to the power of minus m and all other laws. Very important. Only then you will get the most of it. Only then you get the most of the variations of indices. Okay, even you can practice on your own. Okay, okay, having listening to me, and you can do it on your own and practice it, and so that it becomes very much easy for you to do your examinations. Next, a to the power of 3, if you say this one, and directly it is going to be converted to a to the power of 3 by 4. And this is going to be a to the power of 1 by 8. This is 1 by 4 and 1 by 8. This 1 by 2 is because of this root. I am converting this into this is nth root of a form. Now a to the power of 3 by 4 into a to the power of 1 by 8. Now this is going to be a to the power of 3 by 4 plus 1 by 8. Look at this. I am going to apply okay, a to the power of m into a to the power of n. This is a to the power of 3 by 4 into a to the power of 1 by 8. This is going to be, you need to have the LCM of 4 and 8. LCM is 8. 3 by 4 plus 1 by 8. Now this is going to be, we say LCM is 8. This is 4 twos are and 3 twos are, that is 6 and 8, 1 into 8 and 1 into 1. 6 plus 1 is 7, 8 to the power of 7 by 8. This is what the simplified form of this. Okay, even this you can expect in your section C for 5 marks. Now, let me go for the one more problem. This is a to the power of x divided by a to the power of y whole to the power of x plus y multiplied a to the power of y divided by a to the power of z whole to the power of y plus z and a to the power of z divided by a to the power of x whole to the power of z plus 1. You are going to get this answer as 0. Okay, it's only all about 2 steps. That's it. A to the power of x by y, assuming that x is more than y. Okay, this is going to be x minus y. A to the power of x minus y. Okay, whole to the power of x plus y. Now, assuming y is greater than z, a to the power of y minus z whole to the power of y plus z. And here assume z is more than x. Now, a to the power of z minus x whole to the power of z plus x. And remember the formula a minus b into a plus b, that is a square minus b square, that is a to the power of x minus y whole to the power of x plus y. This is the form of the identity a minus b into a plus b, that is going to be a to the power of x square minus y square into a to the power of y square minus z square into a to the power of z square minus x square, and you just add all this and each one gets cancelled. That is a to the power of x square minus y square plus y square minus z square plus z square minus x square. And if you say that x square minus x square minus y square plus y square minus z square plus z square, a to the power of 0 you will get, that is equal to 1. Now a to the power of 0 is equal to 1. This is very simple, and this is no very much important for your 5 marks sections. All these questions are for 5 marks of section C. That is if this is now application of one singular, that's it. That is m by n formula and a to the power of m whole to the power of n. Just two laws I'm applying, and simplified form is achieved. That is a power 0 is equal to 1. Look at this. This is x minus y into x plus y. And directly by just looking at this, no, the given part itself, I can say a to the power of x square minus y square plus y square minus z square plus z square minus x square. Directly you can come to this last step and you can put answer a power is equal to 1. Now let me go to the last one. Okay, that is x to the power of b plus c divided by c minus a 1 by a minus b into x to the power of c plus a into a minus b. Okay, to the power of 1 by b minus c, x to the power of a plus b divided by b minus c into to the power of 1 by c minus. This is bit complicated, bit difficult. Okay, you need to practice it at least for 2 or 3 times to get its learning. This is going to be x to the power of b plus c divided by c minus a, and this is 1 by a minus b, and this is 1 by a minus b, 1 by b minus c, 1 by c minus a. If you take all, let's know LCM, this is going to be okay, a minus b and b minus c and c minus a. And okay, this is here, no, the simplification form, x to the power of b plus c into b minus c, and this is c plus a into c minus a plus a plus b into a minus b. This is a minus b into b minus c into c minus a. This is its LCM part. Okay, I said this is quite difficult. Okay, you have to practice it. Okay, here 2 or 3 steps are skipped. Okay, the LCM part is not shown, and even okay before that there is one more step. How exactly we have achieved this, and you please practice it again. Okay, how this LCM is achieved? A minus b into b minus c into c minus c. This is x to the power of, again apply the same formula, b plus c into b minus c, c plus c into c minus a plus b into a minus b. This is b square minus c square plus c square minus a square plus a square minus b square. Now these things are going to be cancelled, like plus b square minus b square. Now c square and c square, a square and a square. Okay, this is x to the power of 0 divided by a minus b into b minus c into c minus a. The answer is 1. Only thing is this, you need to focus on this particular step, how to get the LCM as a minus b and b minus c and c minus a. For the sake of things making simple presentation, I have skipped one step earlier to this, and you can practice it. Next is last one. Given m is equal to a to the power of x and n is equal to a to the power of y, and m to the power of y and n to the power of x to the power of z is equal to a square, then show that x, y, z is equal to 1. This is a bit tricky. Take this, m to the power of y and n to the power of x to the power of z is equal to a square. Now what is m? A power x. Okay, this is a power x to the power of y into a to the power of y. Here n is a to the power of y to the power of no x, n to the power of x. Here n is a power y to the power of x and whole to the power of z. I'm just transforming, okay, this given case. Now this is equal to a square. Now a to the power of xy into a to the power of yz whole to the power of z. This is x to the power of a to the power of xy plus xy. This is 2xy and whole power z. This is a to the power of 2xyz. We can apply the relation a to the power of m into a to the power of n. Here m and n are both same. That becomes here 2m. Means to say that 2xy. We can take xy as 1m and here xy as 1m. Adding, we'll get a to the power of 2m, and here is z. This is x to the power of 2xyz. If we simplify this, okay, a to the power of xy into a to the power of xy, you'll get a to the power of 2xy whole power z. This is a to the power of 2xyz, which is equal to a to the power of 2. Now, cancelling the common things here, a to the power of 2xyz or a to the power of 2xyz, whatever it may be, or as the bases are same, we can directly equate the powers. Apply this thumb rule. Okay, there is a standard rule to say that whenever the bases are same, we can equate the powers. That is 2xyz is equal to 2, therefore xyz is equal to 1. Okay, if you take the explanation again, taking okay, going for a kind of second round of explanation. Okay, look at this, the data. M is equal to a power x, n is equal to a power y, and m to the power of y into n to the power of x is equal to power z is equal to a square. Correct? Now you take only this LHS part and simplify this and substitute the data what exactly have that is given to you. Now m to the power of y and n to the power of x. What is m? A power x. In the place of m, put a power x and you take y as it is. In the place of n, okay, what is n here? Substitute here a to the power of y and this is x. This becomes a power xy and this is a power yx and xy both are same and whole power z. This becomes a to the power of 2xy. Xy added xy. A power xy plus a power xy, that is a to the power of 2xy. Whole power z is a to the power of 2xyz, which is equal to a square. Look at this. This is what exactly it is all about. Now, as the bases are same, here also base is a and here also base is a. Therefore, I can equate the powers directly. 2xyz is equal to 1. That is xyz is equal to 1. 2 and 2, or you can say we divide by 2 on both the sides. Okay, this is divided by 2 and divided by 2. Okay, this becomes xyz is equal to 1. This is what exactly required. That we have achieved the proof. That's it for today. And thank you very much for giving me an opportunity to address you all regarding the indices and its applications, question paper part. And in the next videos, I'm going to help you regarding logarithms and yeah, proportions as well as even the other chapters too. Okay, you can look forward for my next videos too. Okay, thank you very much. Thank you. Thank you.